Welcome, my dear students. Welcome back. This is a new topic about statistics. Welcome, everybody. This is a new topic in statistics. We will talk today about the standard deviation. Standard deviation. Standard means how far the dispersion of the data from the mean or from the average. How far the dispersion of the data from the average. It's like one of the measures, like as example, when we see if there is a big range between the pays in a factory. There is how fair is the pays in that factory, as example. Are they are very similar to each other, close from each other? Or like someone is taking 1 million and someone is taking 100,000 for a year, or one is taking 5,000 per month and another person is taking only 100 or 200 per month. So it gives us how fair the distribution of the wealth, how fair the distribution of the wages or whatever. We will study here today the standard deviation. Then we will go to the coefficient of variation. We'll take two things. And we will work on the grouped data, not on the random sample, but we will work on grouped data or group data. Okay. I have the example in front of me right now. The example is telling me, like you see here in the board, let me go to the board and work on it. The example is saying, calculate the standard deviation of the below data. Calculate the standard deviation of the below data. The wages, here are the wages, and here are the frequency. The wages and the frequency. So the wages we have, the first wages is the range from 10 to 20. Who are taken between $10 to $20? There are three. The frequency is 3. As example, someone is taking 11, someone is taking 12, someone is taking 15. Those all goes between the category of $10 and $20. And there are 4 persons are taken between 20 and 30. There are 4 persons are taken between 20 and 30. As example, someone is taking 21, another taking 26, another taking 27, another taking 29, between 20 and 30, 4 persons, and so on. 30 to 49 persons are taken between $30 and $40, 9%. And we have also 7 persons are taken from 40 to 50, between $40 and $50. And the last denomination is from 50 to 60. And actually this, we call it, like you see here, it's closed denomination, 50 to 60, closed. Those are opened one side, opened from one side denominations, but the last one is, we call it closed denomination. Okay, closed because it's closed from the two sides, 50 and 60. That's why it is closed from the two sides. Okay, to calculate the standard deviation, our class today is SCT DEV. To calculate our standard deviation, first thing is 1, to calculate the average. Calculate average. Then from there we will go. Then if this is new, no, it's not new because we took the average before. We had the average before. Let us go for the table which we designed today for the standard deviation and our calculus. And we will go from here. Here are the wages. Wages. Here is the F of frequency. Frequency. So what I had in the example by horizontal, I will put it vertical back. And this we had before, when 10, 20, 30, then we have 40, then we have 50 to 60. And the frequency, this is only what I'm doing now is what I got horizontal, I'm putting it vertical back. And the frequency is 3. Here we go, 34975 and the frequency, our frequency of work. Okay, this is the first point. Then we calculated before, to get the average, we will calculate the midpoint. Midpoint, or X, is the midpoint, like we said before. X is the midpoint. And the midpoint, we calculate it how? How we will calculate the midpoint? The midpoint is the start of the denomination and the end of the denomination divided by 2. As example, 10 plus 20, 30, divided by 2, 15. Again, I will say, I will write it here. X is the denomination, center, or the average. So as example, the first one, 10 plus 20, 10 plus 20 divided by 2. This will give me 15. Okay. Then the second one, 20 plus 30 divided by 2. It will give me 25. 30 plus 40 divided by 2. It will give me 35. 40 plus 50 divided by 2. It will give me 45. 35, 45. 50 plus 60, 110 divided by 2. It will give me 55. So X is the start of the denomination, like here, start plus the end divided by 2. And I will go for the next, the same thing. Now I will have a column that is called Fx. I will have a column that I will call it Fx. In Fx, simply, I will multiply F by X. Fx equals column F times column X. Column F times column X. As example, 3 by 15, 45. 4 by 25, this will give me 100. 9 by 35, that will give me 315. 7, 45, it will give me again 315. 5 times 55, 550 to 250, this will give me 275. Okay. Now I think it's very easy for me to get the average. If I calculate these numbers, it will give me 1028. And if the Fx is 1028, and the F is, 1050, this will be 1050. If I calculate it, 1050, if I add them up, 45 plus 100 plus 315 plus 315 plus 275. This, if you do it with the calculator, just to save the time, it will be 1050. Here, the F, the frequency, 3 and 4 and 9 and 7 and 5, this will give me 28. Okay, now I can calculate my X bar or the average. So the average of our X bar, average, we said we have to calculate the average first. Don't forget, we have to calculate the average first. Average or X bar will be summation Fx divided by summation X. Summation F. Summation Fx divided by summation F. So that will be 1050 will equals 1050 divided by 28. And this will give me 37.5. That will equal 37.5. I will make it this side. I will write it on the other side here so that it will be clear. So this will equal 1050, which is Fx, divided by summation F, which is 28. This will give me 37.5. So this was the Fx. This was the Fx. We'll move now to the second part of this equilibrium. And what we want to do today, we want to calculate Fx squared. So now we have Fx, we have X, we are done for the average. We'll move on now. We will do one more column, only one more column, to calculate the standard deviation. What is this column consisting of? Let us see what is this column consisting of. Actually, this column, we'll call it Fx squared. F x squared. So what is the meaning of fx squared? Well, the meaning of fx squared, I will multiply column x by column fx. So I'm done now for this thing. I will erase it. I will erase it. Then I will write the fx squared. Okay. Only what I want here is just to write back that the average or x bar or the average, I got it already, 1050 by 28. This will give me 37.5. And just keep it aside now. I will come to it back. Now I want to add one more column to calculate the standard deviation. How will I get the standard deviation? Then I will say I have to calculate first fx squared. Fx squared equals those two in each other. Now, those two in each other, which is I will multiply x by fx. X column x by column fx. Okay, so the first one, 15 as example. The first one, 15 by 45, 15 times 45, that will equals 675. 675. And so on. 25 times 100, that will be 2,500. Then 35 times 315, that will give me 11,025. 11,025. Then 45 times 315, 14,175. 14,175. Then the last column is 55, 275, 55, 275. It will give me 15,125. 15,125. So this all now is the last column. I'm not going to do any more columns. That's all my work here. Stop. And I will stop here and just I will add them up. I will add all those together. I will add them up, and to save the time, when I finish the calculation and the addition, 675 plus 2,500 plus 11,025 plus 14,175 plus 15,125. When I add them up all together, they will give me at the end this number 43,500. 43,500. Cool. This is the first part. Now I can calculate the standard deviation. Now it's very easy for me to calculate the standard deviation. How will I calculate the standard deviation? We have the formula. I will write it down here right now. It's TDEV, ST, which stands for standard DEV, deviation, will equals, the load or the formula will be like this. Summation of fx squared divided by summation f. Summation of fx squared by summation f minus fx divided by f, summation of course, that's all square. And all this together under the root square. All this together under the root square. Then the root square of summation fx squared divided by summation f minus sum fx divided by sum f all square. It looks very difficult like this, or looks not nice, not comfortable when you apply it with the formula. But when you put the numbers, it will be very easy. Now let us see when we put the numbers how it will look like. It's very easy. Look at this. Equals what? Equals, we have summation fx squared is 43,500. 43,500 divided by the frequency. Summation of the frequency is the addition or the sum of the frequency are 28 minus summation fx is 1050 divided by summation f is 28. But wait a minute, the second part is all square. The second part is power 2. 1050 divided by 28 power 2. So when you finish all this, you will work under the root. Like as example, how you will work. Let me show you. I will show you in this part here. We will make the root square back like this. I will complete the example here. Then I will say the root square. I will keep the root square the way it is. 43,500 divided by 28. This will give me 1553.5. 1553.5. When I divide this number by this number, 43,500 divided by 28, it will give me root square. It will give me 1553. Don't forget the root. We are working all under the root. Minus. Now we will come to do what like this. 1050 you divide it by the calculator by 28, then square it or power 2. You will finish first the division. 1050 divided by 28. You will divide 1050 by 28. Okay. After you finish the division, the number which you will have, get power 2 with the calculator. Okay. So when you're done for this number will be 1406.25. 1406.25. Cool. That's fine. We have the root square now for the two amounts. Still, we can do the subtract now. This minus this, it will give me 147.25 under the root, under the square. It will give me 147.25, 147.25 under the square, the root square. Okay, now 147.25, you give the root square, get the root square of it, then it will be at the end 12.13. 12.13. Here we go, and this is our standard deviation. So the second part of this is only a formula that we apply. We call it coefficient of variation. It depends on the results of what I get. I got, just to highlight back my two results, I got the X bar or the average. The average was 37.5. Like you see here, this is the average. This average was 37.5. I have the average X bar. I can say X bar equals 37.5. And the standard deviation, usually we symbol it with sigma. So we say like this. Standard deviation, or we call it sigma. ST DEV, we give it this symbol, sigma. So now sigma is 12.13. Only I will get use of these two numbers now. I will get use of these two numbers to calculate the coefficient of variation. I will get use of those two numbers to get the coefficient of variation. So here I have 12.13, and I have already done for the standard deviation. I have both of them. I have the standard deviation and I have the average. So how I will get the last thing, or the second demand, coefficient of variation, how I will calculate it? Coefficient of variation, will equals simply will equals the standard deviation, which is sigma, divided by x bar. Sigma divided by x bar. Okay, sigma divided by x bar. That will equals 1213, because the standard deviation is 1213, divided by the x bar, which is 37.5. 37.5. And I will do this with the calculator and see what is the results, how much it will give me. So I will do this with the calculator right away and check out. $12.13 divided by 37.5, that will equals 0.32. That will equals at the end, 1213 by 37.5 will equals 0.32. And this is the coefficient of variation. We call it 0.32. We call it the coefficient of variation. So I got now the coefficient of variation, and I got, here I will raise it up just a little bit, will equals 0.32. And this is my coefficient of variation. Today I calculated again, I would say in very quick minutes, in 2 minutes, I would say again what I did today. I wanted to calculate the standard deviation. So I have now the wages and the frequency of wages. And the standard deviation means how far the dispersion of the data or the series from the mean or the average of the series are there. What it helps in, it helps to see if for any observations there is a fair or there is a great dispersion between the variables. As example, if we are studying the pays, are the pays fair? Means no gap, no big gap between the people. Someone is not taking 100 and someone is taking 1 million, or the gap is small between them, so they are very close in wages and the pays to each other. Anyhow, we will take what was horizontal, we will put it vertical, then we will multiply f by x. First, we have to calculate the average like we did before. We will add one column that's called fx. We'll multiply f by x. By the way, x is the middle of the denominations. 10 plus 20, 30 divided by 2 will give me 50. 20 plus 30, 50 divided by 2, 25, and so on till the end of this column. This column is serving me, but it's not mandatory. I mean, it's not in the calculations, but in the calculations, the fx, when I multiply f by x, it will give me fx. It was 150, and the frequency is 28. So I divide them by each other. I got the average, and I kept the average one side. Okay. Second thing is to calculate the standard deviation. We added one more column that we call it fx square. And in fx square, I will multiply x by fx. I multiply them together, and the final, after add them up, the results of adding up the results, it was 3,43500. I divided this number by the 28 under the root minus the average. So 43500 divided by 28, all this under square root or under root square, minus the average or square. So the average is 1050 divided by 28 all square. So this will give me, after I finish it under the root, it will give me 1213. Okay, how we will get now? So the standard deviation, and we symbol it, we give it a symbol. The symbol sigma is 1213. Now I will go to the last part, which is the covariance or coefficient of variation. Coefficient of variation. Coefficient of variation is simply the standard deviation divided by the x bar. I have the standard deviation. I calculated the standard deviation 1213, and I calculated also the X bar. The X bar is 37.5. Then I will divide them by each other. It will give me 0.32, and this means the dispersion in this factory, if we are talking about wages, is around 32%, which is not very high, and at the same time is not very low. So we find some people are taking more than others, but still the ratio is 32%, which is not considered very high in this concern. Thank you so much for listening to me, and see you in the next class. Thanks for everybody. Bye-bye, everyone.